Today we will be doing surds of the CAT syllabus. What is a surd? A surd is an irrational number which is obtained by taking the square root of an imperfect square. So root 2 is not a perfect square. 2 is not a perfect square. If you take root 2, then that becomes a surd. Now, if you have a surd like root 2 or root 2 plus root 3, then that is called an entire surd. This is called an entire surd. On the other hand, if you have a rational number and a surd, then it is called a mixed surd. So root 2 plus root 3 is entire surd, whereas 5 plus root 3 is mixed surd. Now, if you compare surds like 3 root 2 and 7 root 2, their ratio is a rational number, so they are called like surds. So in like surds, the ratio will be a rational number. And if you have suppose 3 root 2 and 5 root 7, then they are called unlike surds because their ratio will not be a rational number. This particular surd is called a binomial surd because there are two terms and out of the two at least one of them is a surd. So it is called a binomial surd. Now suppose for this particular binomial surd, if we consider another surd 5 minus root 3, then this is called the conjugate surd. So how do we identify conjugate surd? The original surd is 5 plus root 3. The conjugate surd is 5 minus root 3. If two surds are equal, suppose a plus root b is equal to c plus root d, then the rational parts will be equal. So a will be equal to c and the irrational parts will be equal. So b will be equal to d. Now sometimes we are in a situation where we would like to rationalize a surd, which means suppose you have a surd like root a plus root b and you want to make it rational, so you will have to multiply it with root a minus root b. So root a minus root b is called rationalizing factor. So if you have a surd a cube root of a minus cube root of b, then the rationalizing factor will be a to the power 2/3 plus b to the power 2/3 plus ab whole to the power 1/3. Suppose you have a to the power 1/3 plus b to the power 1/3, then the rationalizing factor will be this: a to the power 2/3 minus a to the power 1/3 b to the power 1/3 plus b to the power 2/3. Suppose you have a plus root b, then the rationalizing factor will be a minus root b. So this is how we can rationalize a surd. Suppose you are asked to find the square root of a surd. Suppose you are told to find the square root of 7 plus root 48. So you express root 48 like this, 16 into 3. So you know that square root of 16 is 4. So it will be 7 plus 4 root 3. So that will be root over 7 plus 2 into root 3. And you can see that this is actually the term inside the root is actually the square of 2 plus root 3. So the answer is 2 plus root 3. So in order to find the square root of a surd, you will have to think of a combination which will multiply to give you this irrational part, and the sum of the squares will give you the rational part. So in this way you can find the square root of a surd. Now suppose we want to compare two surds. So let us say that we want to compare 2 plus root 3 and 3 plus root 2. We want to see which one is bigger. So if you subtract 2 from both of them, you will get root 3 and 1 plus root 2. Now you have to compare both of them. So in this case, what we can do is that we can say like this, that we can say that root 3, it lies between 1 and 2, and root 2 also lies between 1 and 2. So automatically 1 plus root 2 will lie between 2 and 3. So if you look at these two, you will realize that 1 plus root 2 is bigger than root 3. So in this way you can compare these two surds. So once again, first you decrease both sides by 2. That becomes comparison between these two. You know that root 3 lies between 1 and 2, root 2 lies between 1 and 2. So then 1 plus root 2 will lie between 2 and 3. So if you compare these two, you can see that out of the two, this is greater. Now suppose you have to compare root 7 plus root 5 and root 10 plus root 3. So first what you do, you square both of them. If you square this one, then after squaring, these are the results. Now subtract 12 from both sides. So these are the two results. Now the problem is that we are still not able to compare both of them. So you square both sides again. So in that case, this will become 140. And this will become 121 plus 4 root 30. So now let's have a look at these two. If you decrease both sides by 121, then this will become 19 and this will become 4 root 30, and now if you square both sides, this will become 360 and this will become 480. So without any doubt you can see that this one will be greater. That means out of the two surds, root 10 plus root 3 will be greater. So this is the method by which we can compare the two surds. Let us have a look at another example of squaring, of comparing two surds. Suppose these are the two surds and we want to compare both of them. So as usual, you square both of them. So now you decrease both sides by 34. Now you need to compare these two. So to compare these two, what you can do is that you can use one calculation that root 30 will lie between, root 280 will lie between 16 and 17, and root 203 will lie between 14 and 15. So 2 root 280 will lie between 32 and 34, and 2 plus 2 root 203 will lie between 30 and 32. So it's pretty clear that this one will be greater. So this is a way in which we can compare the two surds. Suppose if you have an infinite surd like this, so this will be equal to A. Suppose you have a finite surd up to n times, so this will be a to the power 1 minus 1 by 2 to the power n. And suppose you have a infinite surd like this, and suppose the answer of this is P, then P into P minus 1 will be A. So this can be easily proved using simple indices. So these are the various concepts pertaining to surds, and that brings us to an end of this session of surds.